Ever wondered how important sets and relations are in our daily life? Let's start with sets. Picture your favorite collection of books, or consider a group of students in a class. These are examples of sets, which are simply collections of distinct objects. But sets are more than just groupings. They have operations that help us organize these collections in different ways. Think of the union of two sets like combining two different groups of friends to create a larger group. The intersection of sets is like finding common favorite food items among family members. And the complement of a set? Imagine you have a basket of fruits and you remove all the apples. What's left is the complement of the set of apples in the set of fruits. These operations also have algebraic properties which allow us to manipulate sets in various ways, similar to how we manipulate numbers in algebra. So, sets are simply collections of distinct objects, and their operations help us organize these collections in various ways. Now, let's dive into the world of relations. Picture this. You're at your school assembly, and the principal is announcing students' names along with their respective grades. What's happening here is a relation. In mathematics, a relation pairs members from one set, say students, with members from another set, like grades. Now you might wonder, aren't all relations the same? Well, not exactly. There are different types of relations. Think of cities and their populations. New York and Tokyo might have similar populations, but they're definitely not the same city. This is what we call an equivalence relation, where each element of a set is related to itself. Consider another scenario. A group of students and their class sections. Each student belongs to one class section, and each class section has multiple students. This is another example of an equivalence relation. In essence, relations help us understand how different elements within or across sets are associated. Finally, we arrive at functions, another crucial concept in the world of sets and relations. A function in simple terms can be compared to a vending machine. You insert a coin, press a button, and out comes a can of soda. The coin and button input is your set of inputs, and the can of soda is your set of outputs. Now let's delve a bit deeper. Functions can be one, into, or onto. Imagine a classroom of students, each having a unique grade. This is a 1-1 function where each student is associated with a unique grade. An into function is like a recipe. Not all ingredients are used in every dish. An onto function, on the other hand, ensures that every ingredient has a role to play in the final dish. Lastly, the composition of functions is similar to a chain reaction, where the output of one function becomes the input of another. Functions, in a nutshell, are special relations that uniquely associate elements of one set with elements of another. Now that we've explored sets, relations, and functions, let's quickly recap. We began with sets, collections of distinct objects, and then moved on to relations, which define how sets interact with one another. We wrapped up with functions, special relations that pair elements of one set to another. We've seen how these concepts are more than just mathematical jargon. They're tools we use in everyday life to organize and relate information. So sets, relations, and functions play a significant role in organizing and relating information in our daily lives, making them fundamental concepts in mathematics and beyond.